Spokane Cyber Cup, and we are going to be going through the Buffer Overflow KillPtr challenge number 3 series. In the first challenge, we just learned what a buffer overflow was. The second challenge, we learned about idiness and how to write specific bytes. In this challenge, we are going to hijack the control flow of the program that's being executed in order to print out the flag ourselves. Practically, this ends up being almost identical to the previous challenge, but we have to use some GDB and some other ways to figure out some values. So I'm going to copy this as before. For this, we need to overwrite the control flow. The goal is to corrupt the new function pointer in the structure to execute code at print flag. Hint, use GDB to find the address, and hint, here's some helpful code. So what does it mean by the function pointer? If we go to KillPtr.c, you'll notice that there's a new structure here now. Before, we were corrupting special int, but now we are not. We are dealing with this function pointer. So this is going to be 4 more bytes afterwards. So we're going to go down to danger. And now, instead of executing code in case something happens, like we had an if statement before, we're now setting a function pointer to too bad, which does not print the flag, and then we are executing that function pointer. Now, the function pointer is just an address in memory. And it seems weird, but just like this is just some data, this function pointer is also just some data. So if we can corrupt the function pointer, then we can jump to the location to print the flag. If we go to print flag, we actually want to jump to this location. That's really cool, I think. So if we do kill pointer, actually, I think it's easier to do this in GDB. So if we do run and we enter a bunch of characters, actually, we want to be particular about this. We want to send in a bunch of A's. And we do that, you'll notice that an error has occurred, a seg fault in particular. And if we look at the different parts to this, we can see that our AAA is in some spots. Most importantly, though, the EIP, or the instruction pointer, is set to all A's. This is really cool. This demonstrates that we were able to control the location in which the program was moving to. That's really exciting. If we can control the address that the program jumps to, then we can run arbitrary code in the program and tell it to print the flag, even though there is no technical way to do that. Cool, so we've demonstrated what the vulnerability is and how we could potentially exploit it. Now we start doing some counting. So before, we were writing with 32 bytes, and then the rest was going to be in special int. Well, now we need to write 32 bytes in however large this is. Integers in x86 are going to be 4 bytes in size. So instead of 32, we want this to be 36 in size. And if we do that, we should get to this function pointer. So if you go back into GDB, run kill pointer like we did before. Can I run clear? Cannot run clear. So I'm going to do 4, 8, 16, 32, and then I'm going to do 1, 2, 3, 4 more characters for 36. Now I'm going to do B, 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 and yeah, maybe I didn't copy that correctly. Okay, so I'm going to do 1, 2, 3, 4. We're going to do A, so that's 8. This is 32. And then I'm going to do 1, 2, 3, 4 for 36, and 1, 2, 3, 4 B's for the rest of it. Ah, there we go. Must have done something incorrectly the first time. So it's saying we can't access the memory at hex 424242. and that's where the IP is at. So we now know exactly what we need, the offset for what we need to set, which is going to be really useful for the command that we need to run. So the final piece to the puzzle is we don't know the address of it. Right now, we're overwriting it with a completely corrupted value, but we want to jump to the print flag function. We can do this just by overriding it and telling, hey, you should jump to this address. Just like we did with the integers before, we do the same thing with the address for print flag. If we go into KillPtr once again, we can do print, or p print flag. It's just an alias for print. And this actually gives us the address of print flag, which is perfect. Just going to store that there for later. Now if we go back here, and we copy that once again. We know the amount of bytes we need to offset by. It's 32 plus 4, because we're going from the string past the integer. Now, we need to write our bytes in here. So again, I'm going to use my XXD program with -e, so we know we're writing this correctly, because we need to reverse the endingness once again. So we need to write the largest byte first, which is going to be 80. You write, that's going to be 48. That's going to be, I made a mistake. See, there's only 1, 2, 3, 4, 5, 6, 7, because there's a leading 0. So we're going to do 0, 8. 0, 4, 8, 8, 8. And 5, 6. And if you do this correctly, which, we're not at an offset of 4 bytes, so this is confusing the program. Oh, I see. I did hex there. That is bad. We want 36, not hex 36. There we go. Okay. So now we can see the 0, 8, 0, 4, 8, 8, 5, 6. So if we pipe this into KillPtr, then we jump to the wrong spot in the code, aka the print flag function, because we've overwritten that function pointer, which is simply just data. So this is the third challenge of the Buff Overflow series, and we are just hijacking the control flow for this. Thanks everyone for watching.